We're going global, so I'm just about to go away on holiday and I'm taking one of these, which is a Sky Q box, thing here in the UK for watching like UK TV. But the way it talks to its main box, which still gets it by satellite, means they have to be on the same network. So using some tech that I've built, this monstrosity, we're going to be building a GRE tunnel to allow me to watch this in New York. I thought the best idea was to explain how Sky Q works so that you have a basic understanding, and then explain in a diagram what we're going to be doing with the GRE tunnel before we start implementing it. But if you're not interested in that, you can skip to when I start implementing it. So Sky Q works by having what's known as the main box and what is a mini box. So the mini box doesn't have any sort of aerial connections. It just has HDMI and Ethernet. It also does Wi-Fi, but Ethernet will be what we're going to be using for this example. So the main box sits on the same network as the mini box, and then they talk to each other over the network. So they do some sort of bi-directional communication, but they use only protocols that are available locally on the network. So they're using like MDNS for discovery and a lot of ARP and stuff like that. That's how the two boxes actually talk to each other. There's also some massive encryption going on here because Sky don't want you to be able to access any of the streams or any of that sort of stuff. So that's how they work. So what we're going to do is we're going to expand this globally by using something called a GRE tunnel. Editor Thomas here. I've realised I didn't explain what a GRE tunnel is. So a GRE tunnel stands for Generic Route Encapsulation. So when you're doing networking stuff, there are other protocols. So there are like IP, which most of the stuff goes on. But then there are local protocols like MDNS for discovery and stuff like that. Stuff that doesn't work on the public internet. But a generic routing encapsulation tunnel, or a GRE tunnel, allows you to route all of that over an IP packet, such that you can then send it over the public internet. So we're going to have our entry point. That'll be here at the house and is the server upstairs. And then we'll have the exit point. That'll be this device here. This is going to be our exit point. And what actually happens is we create a tunnel between the two, something similar to that. Let's make all this a different color. So this is our tunnel. And now what will happen is we'll take the Sky main box and it'll be there. It'll input its traffic into the tunnel and it'll go all the way through the tunnel and come out on the other side into the mini box. And that way we can expand the network globally. So everything that's on this side will just think it's actually in our house, and everything on this side will think everything over here is just in our house. To all the devices not part of the system, it'll be transparent. So that's simply how it works. So what we're going to do now is I'm going to implement it, and I'm going to show you how we're doing it. I thought it best to show you the hardware. So this is a modified Apple Airport router. It's modified because I've taken the power supply out and using an external power brick, such that inside of here, you don't know how well you'll be able to see it through there, there is a Raspberry Pi in here. And out of it we've got this USB cable which allows me to stick in either a Wi-Fi dongle, which is this TP-Link dongle, or I can stick in a mobile antenna. And then of course the network is coming out and going into the bottom there. So I've got 3 network ports and Wi-Fi connected to the Pi. It will give me a bit of a flashing light. Eventually that'll go green when it's all working. And so I could just connect the Skybox into the back of here such that it would work. So now let's jump into how it's set up. So I've actually got it working. I've just spent some time off camera making sure it works so I know how I'm doing it, and I'll talk you through what we're doing. So we're actually using a VPN in the back end. So the Raspberry Pi in here is talking to the server up there as a VPN. We're connecting using a VPN. This is just a WireGuard VPN, and you can see that here, that we have this peer on the WG VPN and it's connected. If you want to set up a VPN, like a WireGuard VPN, I've got a video about that, but there's loads of videos out there about that. That's pretty simple stuff. So this is giving the Raspberry Pi an IP address of 10.1.2.3, and then the server itself has got an IP address of 10.1.2.1. So now essentially they've got fixed IP addresses. This is always going to be at that address, and the server's always going to be at that address. We need that to set up a GRE tunnel. So we're going to be using the IP-Link GRE tunnel command. So I have a script, the connect tunnel, and I have this set to run when the system boots up. So essentially as soon as the system boots up, it establishes this tunnel as being active. It'll only be active when both devices are booted up, but it becomes active. So what we've done is I've gone sudo IP-Link add GRE tunnel type GRE tap. So you've got tap or turn. for the type of tunnel, similar to you have with the WireGuard VPN. And I've gone local, so the local IP address is 10.1.2.1 to the remote IP address of 10.1.2.3. And I've gone ignore DF and another command, which I can't remember what it meant. But essentially, we're ignoring if it fails. We're just going to keep it up and running. And then we're going to set it as up. And then we're going to set it as master of the bridge. So I've got a bridge interface. A bridge interface allows you to join more than one interface. So I'm bridging a LAN interface and the GRE tunnel. That way they work as kind of one interface. And we're doing the same on here. We're bridging the tunnel and the Ethernet cable that comes out the back. Of course, this bit is not in the bridge. And then we're setting its MTU. This is just the rate at which the data connection happens to 1,500. That I've found to be the most stable. You can set it slightly higher, you can set it slightly lower, but this seems to be the best for speed and everything. So that all runs on startup. I've got that down as a cron job that's set to do on reboot. So all we need to do now is if I go to the IF config, you'll see here it's not up. So we've got the VPN, we've got the bridge interface, but you'll see here we don't have any tunnel for the GRE tunnel. I just need to run this up command. So when I run this up command, that'll bring it up. And then somewhere up here, we've got the GRE tunnel. Here you go. The GRE tunnel is now up and it's connected to this. This has already got its tunnel up. I essentially have the same script wherever it's gone. Where's it gone? I have the same script on the Raspberry Pi. I could show you that now if we cat var/connect tunnel. This is on the Raspberry Pi. It's the same script, it's just in reverse as to what's local and what's not. On the Raspberry Pi, I have this interfaces set up to say that we're going to be using WLAN as an automatic connection, that we're allowing hot swap of that. We want to do DHCP on that. And here are where you'll find the username and passwords. I'm not going to show you that for the Wi-Fi's that it wants to connect to. Of course, you can add more, and you can access the Pi locally when you're on this network using its bridge IP address, even if it's not connected to the tunnel. That way you can update this and get it connected to the hotel Wi-Fi. Then you've got setting the interface to static, and then we're getting an IP address for the bridge, and we're bridging, as you can see here, ETH0 and the GRE tunnel. I do have some other stuff that I've just commented out, but that's all that runs here in terms of interface config, which means that if we go to IF config, you'll see we've got the same VPN connection. That comes up immediately once we have network access. We have the bridge interface, which bridges the Ethernet and the tunnel. Of course, we've got the Ethernet and the tunnel, we've got the loopback, and then we've got the WLAN. That gets an IP address on the local network, whatever that might be, whether that be a hotel or wherever. And then we just use that as a transiting connection to talk to the server. So now that they're up, you're probably going to want me to demonstrate this. So I've got me thingy here, and you can see the orange network cable is not plugged into anything else. And if I plug this into the Mac, give it 30 seconds or so, it takes a moment, it will discover that the USB 10, 100, 1000 LAN connection is connected to the internet and will give it an IP address. There you go, that has worked. And I can demonstrate that we are using the GRE tunnel by, if I take the GRE tunnel down and unplug this connection and plug it back in, the connection will no longer establish a link, and it will say that it is using a self-assigned IP address. As you can see, it's got a self-assigned IP address. So what we would do in this situation is I'll get my Sky Q box, I'll be plugging the network cable into the back, plugging it into the TV, and using this to send the network connection to the server. I won't be demoing that here, but stay tuned, because when I do go to New York, I'll make a short about it and I'll show you how it's all working there. But this is how this works, and I hope you found it interesting. I do love a good GRE tunnel. They're always quite useful, especially when you need to do stuff like if you've got Sonos speakers or AirPlay, all that sort of stuff. It all works over this. So everything on this thinks it's at home, and everything at home thinks everything here is at home. If you've enjoyed this one, hit the subscribe button and the like button, and I'll see you in the next one.